Okay, so we're going to talk through exercises 1 through 3 here. So they all three of those use this diagram. So hopefully you found the questions on the next page. If not, those are the exercises, so you can pause and look at them before you listen to me talk about them. Okay, so I'm going to read number 1, and it says figure A, which is this one right here, was translated along vector BA, which is right here, resulting in translation of figure A right here. So if you want to use your overhead to try that, then it would look like this. So I could trace out my vector, and A, trace my figure, translate along the vector, and show that that's the image right there. Okay, so, but what's our question? Let me get this back in here. Describe a sequence of translations that would map figure A back onto its original position. Okay, so like we just said, if I want to map it back onto its original position, then I'm going to need to translate along a different vector, and I'm going to use vector AB that way. So I want to translate the translation back, and it's going to look like this. So if I translate on vector AB, then it will take me back to figure A. So let's see how we would write that. You should have something. So we translated figure A along vector BA. So to get it back to its original position, the next thing in the sequence, so let's write the whole thing. So we translate figure A along vector BA, then translate the image of figure A along vector AB. And I can write vector AB like that. So we translated figure A along BA and then translated the image of figure A along AB. Okay, so let's look at the next one. Bring my picture back up here. So here we are. Figure A was reflected across line L, resulting in reflection of figure A right here. Describe a sequence of reflections that would map figure A back onto its original position. Okay, so this one's pretty simple, right? We're just going to reflect it back because, as we just talked about, a reflection is its own undo or its own inverse. So we reflect figure A across line L. Then reflect, and this is just getting us back to our starting point, reflect the reflection, then reflect the reflection across line L again. Okay, so we reflected it, and then we reflected the reflection, and we got back to where our original position. Okay, so here's a question. Can translation BA, and that's this vector over here, of figure A undo the transformation DC of figure A? why or why not? Well, hopefully you can see that I've still got this drawn. So here's figure A. If I translate this along DC, it would take me over this direction. And then if I take this image along vector AB, it's going to move me down here. So that's not an undo for that. That's pretty intuitive. So hopefully you could see that the answer to that would be no. That no. Can translation be a undo the transformation of translation DC? To undo the transformation, you would need to move it back to its original position. So if we move down this way along DC to get back, we're going to need CD, and this would not be that translation, the undo of that. So go ahead and you can write that out for exercise 3, and then we'll come back and do another example together.